Friends, we are discussing the list operations in the language LISP. We discussed car, which takes a list as its argument and takes out the first element as the value returned for the operation car. Then we discussed briefly the CUDR operation. The CUDR operation again takes a list as its argument. However, the value returned is the list which is obtained by dropping the first element of the given list as argument. Friends, in this particular case, we discussed a few examples also. The name of the operation is CUDR, however the spelling is CDR. The word CDR, which represents the operation of CUDR, is pronounced as CUDR. Now we must note in this particular case that the argument of both car and CUDR must be a list. In case the argument is not a list, then error will be returned. For example, on the slide, please look. We are given CUDR quote X. Now we know that quote X, when evaluated, returns the symbol X, which is not a list, and hence CUDR quote X is an error. However, if the symbol X is already associated through set Q to a list, say ABC, and we are given the operation CUDR X, not CUDR quote X. Please try to differentiate. CUDR quote X will return an error. However, CUDR X without quote may not return an error if the symbol X has already been associated with a list, for example, through set QX quote ABC, because then CUDR X actually means CUDR of the list ABC, and the CUDR of the list ABC is nothing else but drop the element A, whatever is remaining, that is the list BC, should be returned. Now in some of the situations, it may be possible that we want nth element, say fourth element. We are not interested in the first element of a given list, but rather in the fourth element. Then what we should do? Well, in this particular case, if it is fourth element, we can apply CUDR 3 times. Every application of CUDR drops the first element, gives a new list, and therefore 3 applications of CUDR will drop the first 3 elements, and whatever is remaining of the list will be given as an argument to the next operation, which we may take as car. And now the car will give the first element of the remaining list, which is actually the fourth element of the given list. So in general, if we are interested in finding out the nth element of the list, where the number of elements in the list is more than or equal to n, then what we should do in order to find out nth element of a given list, what we do, we apply n minus 1 CUDRs, and whatever is obtained, we apply finally a car. So what will be how the nth element will be obtained? We will write an expression or a Lisp object like car CUDR, CUDR, CUDR n minus 1 times and the given list. This will return the nth element of the given list. For this purpose, you can see, for example, on the slide, car, CUDR, CUDR. So what does this? And then a list is given, quoted list. Quoted list is evaluated to a list which is without quote, and because there are 3 CUDRs, therefore we are interested in the fourth element, and you can see in the list the fourth element is K76. Therefore K76, which is the fourth element in the given list, will be written. When we are counting fourth element, I have said a number of times earlier also that if a list is itself an element, then it will be counted as a single element. For example, name Raj, bounded by pair of parentheses, represents a list, and therefore it is a single element, so it will be counted as second element. Person will be counting as first element. Name Raj list bounded by pair of parentheses will be the second element, and residence etc. whatever is the complete list will be returned as third element, and so on and so forth. We must be careful about this. Okay. Now it may happen that in a situation we are using a number of cars and couders in different orders. 2 cars may be followed by 3 couders, then followed by 2 cars, etc., etc. Now writing cars, couders, etc. may be a very lengthy, may lead to a lengthy expression. So then the designers of the linguists have thought of this problem, and they have said, okay, in such a situation some of the C's and R's may be dropped. For example, if you look at the slide, we have a car followed by a car, followed by a couder, followed by a car, followed by a couder, followed by another couder. How we can simplify? You can see in the 2 words car and couder, they differ by A and D. C and R are common. So in order to differentiate a car from a couder, we may use just A, and to denote couder, we may write just a D. So what we can do, C and R may be dropped from each of the cars and couders except a first C and last R is maintained. So we can write A for car and D for couder must be preceded by C followed by R. It may represent a sequence of cars and couders. So here we have C followed by A, followed by A, followed by D, followed by A, followed by D, followed by D, followed by R. What it represents? It represents a sequence of cars and couders. First is a car, second is a car, third is a couder, fourth is a car, fifth is a couder, sixth is a couder. So this represents 6 cars or couders. We can break it up into 2 threes also. For example, first 2 cars may be written as C-A-A-R. Then the next 4 operations of couders and cars may be written as C-D-A-D-R, etc., etc. So what I mean to say, that cars and couders, a sequence of cars and couders may be simplified in its notation by dropping C's and R's except the first and last. Now the next very important operation is cons. So far we have discussed 2 list operations which extract something from the already given list. But sometimes we need to build up a list. What are the operations available in the language LISP to build up lists? For example, we want to build a list of the employees of a given particular company, names of the list. So what we can do? We may make a list which is empty in the beginning, then we put the first name in the list, then we put the second name in the list, then we put the third name in the list, and go on like this one. What are the constructs in the language LISP which allow us to add names to a given list? So cons is one of the operations which build up the list. They don't take out elements from the already given list, rather they build up a list. So please look at the slide. So here we have got the operation cons. What it does, cons takes 2 arguments. The first is any S expression, but the second must be a list. And what it does, first of all, the cons operation evaluates its arguments. In this particular case, quote star and quote 47 list are 2 arguments given to cons. So quote star evaluates to star and quote list 47 evaluates to the list 47. So ultimately what will happen, the first arguments evaluation is inserted as the first element in the new list, which is obtained by the first symbol or first argument's value inserted as the first element of a new list, in which the remaining elements are coming from the second list. So in this particular case, cons star 47 will lead to the list star 47. Similarly, cons AB, it is not necessary that the first argument must be a symbol only, it may be list also. So cons quote AB, quote BC, so first thing cons does is to find out the values of its arguments, and the value of quote AB list is the list AB, the value of the second argument quote BC is the value BC, and then what is the next, that the whole list AB is placed as the first element of a new list, which is obtained by keeping the elements of the second list in the same order, but the first argument's value is placed as the first element of the new list. Cons A nil. Now quote A. Now quote A evaluates to A. Nil list means a pair of parentheses not containing anything. So in this particular case, A is inserted and we will be getting the list A. Then friends, another way of building lists is a list operation. List is a data structure, list is a constructor function also. That is, list as a function is used to give new list from its arguments. And how the list operation, please try to differentiate between the two. List is used as the name of a data structure, list is used as an operation to build new lists. How this operation list works, for that we should look at the slide. Please, slide says the list may take any number of n expressions as argument. The function list first of all evaluates its arguments, and then the arguments so obtained are grouped into a list in the same order as the corresponding parameters are given initially. For example, you have first of all two operations, set q x quote AB. What would happen? This will return, associate the list AB as with the variable x, and in addition set q x quote AB will return the value of the list AB as one of the values. Similarly, set q y quote intelligence, what it will do, it will associate the symbol intelligence with the symbol y, and in addition it will return the value intelligence also. So now if we have an expression, the left parenthesis followed by list followed by quote x, y, x, quote knowledge, quote y, what it will do? The list function or list operation first of all finds out the values of its argument. The arguments are 5 in number. The first argument quote x evaluates to x. However, the second argument is not quoted, it is y. Therefore, what the system will do? Has y been associated some value through some set q operations earlier? Yes, it has been associated the value intelligence. Therefore, y will be replaced by intelligence. The third symbol x is again not quoted, and therefore what the system will do? The system will try to find out a value which has been associated with the symbol x through some earlier operation set q, and we know that the symbol x has been associated the list AB. So now this symbol, third symbol x, will be replaced by list AB. Please note, the first one was quoted x, and the value of quoted x is x, whereas the third symbol is x, which is not quoted, and therefore its value AB is replaced by replaces it. The fourth argument is quoted knowledge. and quote knowledge evaluates to knowledge, therefore knowledge becomes the fourth element of the new list, and finally y quoted evaluates to y, therefore this value of quoted y, which happens to be y, is placed as fifth element of the list. So the list operation, which had 5 arguments, works like as discussed earlier. That is, first of all, in this particular case, its 5 arguments are evaluated one by one, and the values are placed as elements of a list in the order in which their arguments, corresponding arguments, occur. So the final answer to a list quote x, y x, quote knowledge, quote y is x, intelligence, then another list AB, knowledge y. Then there is another operation quite similar to list, which is called append. The difference between list and append is this, that in the case of append, all its arguments must be lists. They may not be just quoted symbols. And when final answer is to be returned, the arguments on evaluation should come out to be list. Their pair of parentheses bounding them must be removed. That is, here the difference is that append, its arguments must evaluate to lists, and while returning a list, the elements which are obtained on evaluation of the arguments of append, the pair of parentheses bounding the lists which are obtained as values of the arguments of append must be removed. Let us have an example for this one. Please look at the slide. For example, we associate the list AB, quoted list AB, with X. So set X quote AB, what does this do? This associates the list AB with the variable or symbol X. Similarly, set Y quote CD, what it does, it associates the list CD with the symbol Y. Now, for example, we have got the construct append XY quote double left parenthesis AB double right parenthesis followed by the closing right parenthesis. What would happen? First of all, as I mentioned earlier, in the case the arguments of append are evaluated one by one. So X is evaluated. What is the value of X? The list AB. So it is noted list AB. Similarly, the value of Y's argument, which is quoted list CD, is found out, which is list CD. So what happens next? That now the pair of parentheses binding these two lists are removed. So the pair of parentheses around the list AB are removed and we get the element AB. Similarly, the pair of parentheses which is bounding the list CD are removed and we get the two elements C and D. And finally, the last expression or third argument of append, which is double left parenthesis, that is, it is a list of lists, a list of a single list AB which evaluates to a list of lists. So if you remove the pair of parentheses, still you are left with a list, and hence the append, what it does, it removes the outermost pair of parentheses and writes the elements in the sequence of its arguments, and hence we will be getting append XY quote double left parenthesis AB double right parenthesis followed by right parenthesis becomes ABCD and a list AB. Here I must tell you, once again I remind you, that the last list does not have 6 elements but 5 elements. The first element is A, the second element is B, the third element is C, the fourth element is D, and the fifth element is not A. The fifth element is actually the list AB. I have a number of times mentioned it, that whenever a list occurs as an element of another list, then whole of the list is treated as a single element of the upper level list. Then friends, sometimes we want to reverse the order of the elements in a given list. This function reverse, which is inbuilt in the language LISP, does the job. But again I mention that if an element is a list, then the whole of the list is taken as a single element. In the light of this, let us have a look at the slide how the reverse operation works. Let us think reverse, and its argument is a quoted list. So first thing what happens, the quote is removed in order to find out the value of the list. So the value comes out to be the list containing 4 elements. The first element is A, the second element is B, the third element is the list AB, and the fourth element is the list CD. Now what reverse will do? The whole list CD will be treated as a single element, and it is the last element. So in the after application of reverse, CD becomes the first element. And note that CD's elements are not reversed, because C and D are not the elements of the given list. Rather, the list CD is an element of the given list, and therefore CD's order will not be replaced. Only CD becomes the first element. Similarly, the next element from the reverse side is a list AB, and therefore AB becomes the second element of the list returned as value of application of reverse. Now the next element from the right hand side is B, and therefore B is returned. And finally, because the first element of the argument list given to the reverse operation is A, therefore A becomes the last. So repeatedly I say that whenever a list itself is an element of the given list, then that should be treated as a single element and not a more than one element, depending on the number of elements within the list which is an element of the list. It is not the within elements which matter. Friends, sometimes we need to find out what is the number of elements in a given list. For example, we have the list of employees of a particular company. Now we are not interested in who are the members of the company, rather how many are the employees in that particular company. But we are given the list of the employees, names, etc. So length is an operation which can be used for this purpose in order to find out the number of employees where the list of employees is already given to us. So what length does? Length has an argument which is a quoted list. The quote is removed, we get a list. Then length counts the number of top elements. Again I say that if AB is a list AB is given as one of the elements, it will be counted as 1, not 2. So in the light of this discussion or explanation, please have a look at the slide, and we are finding out the length of the list in which the topmost elements are first element is A, the second element is a list AB, the third element is the list CD, fourth element is the list E, not list but an element E. Therefore, the given list which is given as an argument to the function length has 4 elements, and therefore the length of the given list will be returned as the number 4. I hope it is clear. Last, sometimes instead of being the first, being interested in the first element, we may be interested in the last element. So one way is to reverse and then find out the cons. The other is that inbuilt function reverse is given to us, which may be implemented as taking the reverse followed by car. So the last, what it does, it returns the last element of a given list. But again I repeat, if the last element happens to be a list, then the whole list is returned. So let us have a look at the slide. Last of the list, quote A, B, another list CD. So the last element of this list is CD list. This has to be kept in our mind, that it is not D which will be returned, rather it is the list CD which will be returned. Substitute. Sometimes we find that a list of employees or something is given to us and we find a particular entry is not proper. A spelling mistake has occurred in which say every A should be replaced by E. What is the mechanism in the list definition? So friends, substitute, S-U-B-S-T, is a inbuilt function in the Lisp language which replaces its second argument by the first argument. In order to have further clarification in this respect, let us have a look at the slide. So friends, what we are given? We are given subst, quote A, quote B, quote A list. So substitute, which is written as S-U-B-S-T, takes three arguments. The last must be a list, and there are two other arguments. All three arguments are evaluated, and the value of the second argument, if it occurs in the value of the third argument, then the value of the second argument is replaced by the value of the first argument. In this particular case, what happens? Substitute has three arguments. The first argument is quote A, the second argument is quote B, and the third argument is a list, quoted list rather, which has three elements DBA. So what this substitute does, that it finds out the value of quote B. The value of quote B is B. Now B is located in the list which is obtained by evaluation of the third argument, and if it occurs somewhere, then it is replaced by the value of the first argument, and the first argument is quote A, the value of which is A. Therefore all occurrences of B are replaced by the A's. So in this particular case, a D which occurs at second place is replaced by A, and hence the list which is returned is D followed by A followed by A. Similarly, we must be very careful that it is not necessary that the first and second arguments must compulsorily be symbols. No, it's not like that. They may be lists also, quoted lists also, and in that particular case, the value of the second argument is replaced by the value of the first argument, whether these arguments may evaluate to symbols or to lists. So let us consider an example where the first or second or both of these arguments may evaluate to list. Please have a look at the slide. So here this is substitute quote AB, quote C, quote D, B, A, C. What does this say? First of all, it will evaluate its second argument. Second argument is quote C, which evaluates to C. Now all occurrences of C in the third argument's value must be replaced by the value of the first argument, which happens to be the list AB. Therefore C is replaced by the list AB, and the value which is returned is D remains same, followed by B which remains same, followed by A which remains same. However, C is to be replaced by the value of the first argument, which happens to the list AB, and therefore the list which is returned is DBA and a list AB. Then friends, we discussed a number of arithmetical operations, then we discussed a number of list operations, and in between we told that the Lisp language mainly is used for list operations and not numerical operations. Now in the process we may discuss a very important function, eval. What it does, that when the arrow pointing towards the right direction is given as a prompt, which indicates that the system expects some input from the user. Then I told you, when a value is given by the user followed by a return or enter, then what would happen? Whatever is entered, if it happens to be a legal expression of language Lisp, it is evaluated. First of all, it is read character by character. Once it is read, it is formed into an expression, and this expression is evaluated, and finally the value is returned. So read, eval, print or return. Now sometimes it may happen, whatever is the value returned may further require another evaluation. For that purpose, eval function is provided in the language Lisp in order to evaluate some of the values which have already been evaluated in the process of read, eval, print loop. So for this purpose, let us have a look at an example on the slides. For example, set q x quote y. Please look at the slide. We have got, please look at the slide. For example, we have set q x quote y. So what will this will evaluate? That the symbol y is associated with the symbol x. Now we have set q y z. What does this do? It will first of all find out the value of the variable z, and that will be associated with y. So friends, if we have eval x, what it will do? First of all, x is already associated with y as its value. Now that value is replaced whenever x is written. Instead of x, y will be there, because every function's arguments are evaluated. Had it been quote x, then quote x would have evaluated to x, but because it is not quote x, it is just x, and x has been associated the variable y with this, therefore eval x will be actually what it will be doing. First x will be replaced by y, and then eval y will attempt to find out the value of y, but because set q y z is already given, therefore y actually evaluates to z, and therefore eval x will return z and not y. Next, friends, we discuss some predicates. Predicates are special type of functions. What are the speciality? That in that case the argument must map either to true or false, or it may true to 0 or 1. That is, predicates are those functions whose arguments map to true or false. We want to discuss what are the inbuilt predicates in the language Lisp. Please, for this purpose, let us have a look at the slides. Slide says greater than 7, then list plus 2, 3. What would happen? Because I just now mentioned that greater than is actually a symbol which represents an operation, and whenever an operation is to be applied, it must be, its symbol must be written as the first symbol within the list. So greater than is evaluated, and it is representing the operation greater than. That is, it will check whether the first argument is greater than the second argument or not. Now what is the, and all the arguments are evaluated. 7 evaluates to 7. However, the second argument is plus 2, 3 list. It is evaluated, and in order to evaluate, because there is no quote, therefore the list plus 2, 3 is attempted to be evaluated. That is, in this particular case, the operation plus is to be applied to its second and third arguments values. So 2 evaluates to 2 and 3 evaluates to 3, plus is applied to these, 5 is returned, and therefore ultimately whatever is given becomes equivalent to finding out whether 7 is greater than 5 or not, and we know that 7 is greater than 5, therefore true is returned. Similarly, again 7 less than 7, 3. It checks whether the number 7 is less than 3 or not. If it is less than 3, then true is returned, and if 7 is not less than 3, then nil is returned, and we know that 7 less than 3 is not true, therefore nil is returned. In this context, I may again repeat that nil represents false. The value false in Lisp is represented by nil. Now we come to another very interesting example here, that equal to is again a predicate which checks whether the two numbers which are given as second and third arguments are those really equal or not. If they are equal, then true is returned, otherwise false is returned. So in this particular case, you can see the first argument of equal symbol is *37 list, and because it is to be evaluated, in order to evaluate, the star is interpreted as multiplication, 3 evaluates to 3 and 7 evaluates to 7. Therefore the star operation is applied to two values of its arguments, which are respectively 3 and 7. The answer comes 21. So whole of the list *37 is replaced by 21. Similarly, plus 16 5 evaluate to 21, and this plus 16 5, the whole list is replaced by 21, and we know equal 21 is true, therefore true is written. Then the equal word is there. That equal sign was for numbers. However, EQUAL is for lists. So what it does, it takes two arguments, and if their values are same, then it returns true, otherwise it returns false. So please look at the slide. We have got two arguments of equal. First is a list in which two elements are there. One is a symbol 1 and the other is a symbol 2. And the second list also has two elements, and the first element is 1 and second is 2. And therefore you can see, structurally the two lists are just identical, therefore equal will return true. However, we will see there are some similar operations which are not spelled as EQUAL, which have some similar function but not exactly same, which we will discuss within a minute or two. Similarly, please look, equal code 2-1 is not same as the list 1-2, because the order of the elements is different, and therefore in this particular case, equal the first list quoted and the quoted second list, their values will not be same, because the order of elements in the two lists is different, and therefore it should return nil. Finally, we need not give arguments as lists only. We may give arguments which involve functions, etc., but ultimately their answers should come out to be a symbol or a list. So third example shows equal quote AB, and the second argument is not a quoted list but car of ABC, etc. Now what would happen? The first argument is a quoted list, therefore the value of that will become the list without quotes. In the second case, because there is no quote, we try to evaluate the second list, and because the first element of the second list is car, which is a function, therefore it is to be applied to its argument, which is ABC, a list, and the car of that will become AB list. Now you can see the first argument evaluates to the list AB, the second argument evaluates to the list AB, and therefore two being identical, therefore equal, this of its argument returns T, true. Then there are other predicates. Other predicates check for other truth and false functions. Even P, what it does, it takes argument as one number, and if the number happens to be even, then it returns true, otherwise it returns false. For example, if we have even P plus 4 7 without quotes, now because the list is not quoted, therefore the operation plus is applied to its arguments 4 and 7, which comes out 11. But we know 11 is not an even number, therefore even P of plus 4 7 leads to nil. And even P, if we are given a list *25, now the list *25, if it is not quoted, then it is when in the process of evaluation the multiplication operation is applied to its arguments values 2 and 5, which comes to 10, and we know 10 is an even number, therefore even P star to 5 list yields true. Then number P. Sometimes we want to check whether a argument is a number or not. Because if we want to divide some entity and it happens to be non-number, then the operation will lead to error. Therefore, it is better to check whether the given argument is a number or not. For that, in LISP, the provision is there of the predicate number P. Please look at the slide, number P 2.146, etc. It is a number. And being a number, number P, note the number P. P indicates predicate. Number P quote X. Now you know quote X will evaluate to X, and X is a symbol, not a number. Therefore it evaluates to nil. Further we have suppose set Q 50 symbol. Now 50 FIFTY is a symbol. However, this symbol has been associated with the value 50, and therefore number P 50 will become true. But in the last line, number P quote 50. Now quote 50 evaluates to 50. However, 50 is FIFTY is not a number. The value of FIFTY is 50, but quote 50 FIFTY evaluates to FIFTY, which is not a number. Therefore, number P50 will give you us nil. Then there is a mechanism of checking for 0, whether a given number is 0 or not. If it is given number is 0, then it returns true, otherwise it returns false. So 0P0 is true, and 0Px, where x has been set to 0, is again true. 0P quote x is nil, because quote x evaluates to x, and x is not a number. Similarly, 0P dot 0001, etc. also returns to nil, because despite dot 000001 is a very small number, but it is not equal to 0, and hence 0P will return false. There is a predicate null. Now null actually is a predicate. Nil is a atom. Nil means false, whereas null checks whether something is empty or not. Please try to understand the difference between the two. Null, N-U-L-L, is a predicate when it is given an argument, and if it is not a nil list, then null will return false. However, if null is given an argument which is a nil list, then in that particular case it will return true. So this is how we can define the null. Friends, we have discussed a number of essential characteristics of the language LISP. So in this there are some very important features which need to be discussed, like how we define iterative functions, how we define recursive functions, etc., which we will be taking in the subsequent lectures. Thank you very much.